Well, the next problem we've put up on the board is straight in front of us. Evaluate the integral 0 to infinity e to the power of minus x, e to the power of minus of x to the power of n, not minus x to the power of n, it's e to the power of minus x to the power of n multiplied by x to the power of m in terms of beta gamma functions, The next part is, by choosing n is equal to 1 and m is equal to minus half in whatever we get above, check whether a tenable result is obtained. Tenable result, the word tenable comes from an English word tenet, T-E-N-E-T, which is truth. So, tenable means truthful. That means whatever we should get should not be a contradiction. So, we will just capture these values. We have to choose n is equal to 1 and m is equal to minus half. So, we can rub out this part, and the basic integral is there on the board, e to the power of minus of x to the power of n multiplied by x to the power of m. And of course, we have to put a dx here, that's understood. Now, what we will do is, to get it into a gamma function form, we will get this x to the power of n term as a linear quantity. That means we will take a substitution, which is an obvious suggestion from the question, that we say let us take x to the power of n as z. This implies n x n minus 1 dx is dz, and this implies that, my friend, dx is equal to dz over n x to the power of n minus 1. Now, we have to convert this to terms of z. We will do that very shortly. So, dx is equal to dz over n x to the power of n minus 1. We capture this here. Dx is equal to dz over n x to the power of n minus 1. We convert it to z and then write it down there. Now, we remove this space, but remember that we have taken x to the power of n to be equal to z. We have taken x to the power of n is equal to z. Now, to get x to the power of n minus 1, we can see that if we raise this to the power of n minus 1 over n, then we get z to the power of n minus 1 over n. So, what we do is we write this a little better way. X to the power of n is z. So, raise this whole thing to the power of n minus 1 over n to get z to the power of n minus 1 over n. And on the left hand side, we can see that this is nothing but x to the power of n minus 1 is equal to z to the power of n minus 1 over n. So, we will put that value here, n x to the power of n minus 1, we cut from here and write that this is equal to dz over n, that is fine, and x to the power of n minus 1 is z to the power of n minus 1 over n. So, these are important captures which we will utilize now. What about the limits? The transformation was x to the power of n is z. So, the upper limit will be also infinity, and when x is 0, z is 0. So, after substitution, we can get the reduced integral. We can write that here. After substitution, what we get is the integral that we put up on the board is same limits 0 to infinity for z, e to the power of minus z. That's there. X to the power of m. Now, x to the power of n was z, so x to the power of m obviously is z to the power of m by n. In other words, if I raise this to the power of m by n, I will get x to the power of m. X to the power of m. Raise this to the power of m by n, then I will get n by m. We got x to the power of m though. That means this m by n. Yes, it's all right. It's perfectly all right. X to the power of n is z to the power of m by n. So, having done all that, we will rub out this part, take all these captures and modify this integral to read in terms of z alone. And we write I reduces to 0 to infinity e to the power of minus z. That's fine. X to the power of n is x to the power of m is z to the power of m by n. Dx is dz to the power of dz n and z n minus 1 over n. That's all right. Now I can afford to rub out all the work that we have on top and just live with this particular integral. There's a little bit of work to be done. We'll do it very carefully. So we're now going to simplify this and write this as equal to 0 to infinity e to the power of minus z. There is a n outside. Denominator we put it outside, so 1 by n e to the power of minus z, and this becomes z to the power of on top m over n minus n minus 1 over n dz. So everything has been captured in terms of z. We will simplify one more step and write this as 1 over n 0 to infinity e to the power of minus z. Now this is z to the power of, the denominator is the same, so m minus n plus 1. Over n. That's it, dz. Now we have to cast it into the form of a gamma function. Now this is gamma of not z to the power of this much, sorry, not gamma of this quantity, but gamma of this quantity plus 1. So this quantity, if we add 1, we get m minus n plus 1 plus n. So m plus 1 over n. I hope this is understood. When we have e to the power of minus z into t to the power of or z to the power of p, it is gamma of p plus 1. So we've added 1 to this. If I add 1, then there is a n which annihilates this, and there is m plus 1 over n. So That is my final result. Our friend here is nothing but gamma m plus 1 over n. So the original integral with which we started reduces to gamma m plus 1 over n. Now we'll put back the original integral and put back this result, and then we will substitute for n 1. I remember we had to take n as 1 and m as minus half. So we'll get back to the original integral and substitute n with 1 and m with minus half and see if we get a tenable result. We can write down the conclusion as follows. The conclusion is integral 0 to infinity e to the power of minus x to the power of n x to the power of m dx is nothing but gamma m plus 1 by n. Now on left hand side, let us put n as 1 and m as minus half. Substituting n as 1 and m as minus half, the LHS becomes 0 to infinity e to the power of minus x to the power of 1 and x to the power of minus half dx, which is nothing but this minus half is half minus 1, so this is nothing but gamma half. Straight away from properties of gamma functions, if we write x to the power of minus 1 minus half means gamma of half. What about the right hand side? The right hand side also becomes gamma minus half plus 1 over 1, which is gamma half. So the left hand side and the right hand side each reducing to gamma half means that we have indeed got a tenable result, and the integration that we carried out, which was looking a bit difficult in the beginning, is perfectly all right and simple. With the last problem which I put up on the board for this basket of problems, probably the fifth or sixth, reads thus: evaluate 0 to pi by 2 under root of tan x with respect to x by using beta gamma functions. By using beta gamma functions, normally in an examination no question may be worded like this. You may just be asked to evaluate this, and then if hands are not tied down, this is tying down the hands, because the examiner wants to test a knowledge of beta gamma functions. So he or she says that use beta gamma functions forcibly, and if that happens, if the question is worded like this and the student answers it by using some other methods, the credits will of course sharply fall for this particular question. So what we will do is, we will rub out the question and then get a formula that we have done earlier. All of us know from an elementary study of beta gamma functions that we know 0 to pi by 2 sine to the power of px cos to the power of q x dx is nothing but gamma p plus 1 by 2 gamma q plus 1 by 2 over 2 times gamma p plus q plus 2 over 2. This is a standard formula that reduces any integral of the form 0 to pi by 2 sine to the power of p cos to the power of q in terms of gamma functions. Now, our integral is 0 to pi by 2, the one we are looking for, root tan x dx, that is 0 to pi by 2 sine x to the power of half and cos x to the power of minus half dx. So straight away one can see that p is half and q is minus half. So it stands to reason to believe that this particular integral will be nothing but gamma half plus 1 by 2 half plus 1 by 2 gamma minus half plus 1 by 2 over twice gamma, add them up, p plus q is 0, add 2, divide by 2, so gamma 2 by 2, which is gamma 1, and gamma 1 is of course 1. That is another property which we've seen earlier. So we now have to just reduce or simplify this. The denominator stands at 2, the numerator becomes gamma 3 by 4 and gamma 1 by 4. So the net result is we have to simplify, we just have to simplify half of gamma 3 by 4, gamma 1 by 4. We want to simplify half of gamma 3 by 4, gamma 1 by 4. That is the answer. Let's see if we can simplify by means of the duplication formula, which states that gamma n into gamma 1 minus n is pi over cosec n pi. Pi sine, pi over sine, pi cosec n pi, sorry, not pi over, it's pi cosec n pi. There we are. Now, my friend here is, this is equal to half gamma 1 minus 1 by 4, that is 3 by 4, gamma 1 by 4. So this is half of pi cosec pi by 4. So this is half pi. If sine pi by 4 is 1 by root 2, cosec pi by 4 is just root 2. So the net answer is pi over square root of 2. That is the value of the integral that we were looking for.